Welcome to the technical report for ASHRAE Student Design Competition 2014, Integrated Sustainable Building Design. This is the University of Belgrade student branch, and members are Tamara Bajc as a team leader, Miloš Milijašević and Svetlana Bajović as students of Mechanical Engineering, Nevena Krajinović and Marija Stanojčić as students of Architecture. Our faculty advisor is Maja Todorović, PhD. The aim of this project is to provide a sustainable design taking into account energy efficiency, functionality, flexibility, health and safety, as well as productivity while minimizing their impact on the environment. This project includes the renovation and technical systems improvements of a two-story office building in New York City. Here we see HVAC system design criteria. The main goal of this project is to provide efficiency, health and safety, comfort, longevity, flexibility and maintainability, taking into account a sustainable design. Systems are selected to provide design requirements for the lowest possible cycle cost that includes cost of materials and long-term operating costs. Buildings should conform requirements ASHRAE 189.1 as a minimum. Excellent indoor environment quality requirements are considered according to ASHRAE Standard 55. Here we see ASHRAE standards that are used in this project. The climate of New York State is broadly representative of the humid continental type, which prevails in the northeastern United States. Here we see temperature, wind speed, wind direction, atmospheric pressure and solar radiation site data for whole year hourly. The main criteria for the site selection were large undeveloped site, distance from densely developed central zone of the city, mostly industrial area, close to the water. The selected site is located in the southern western part of the island of Long Island in the city area Brooklyn, Greenpoint. The site is surrounded by Noble, West and Oak Street, and access from those streets to the site is planned and designed, while the western part is oriented to the East River. The site is long-sided oriented to the north and south. Currently, it is prefabricated warehouse of building material and is completely undeveloped and under construction. Here we see site selection according to land use in New York. This is existing building model before renovation that is designed according to building assumptions that are proposed in competition project requirements. For the existing building with assumptions that are proposed in the competition requirements and for selected site, various simulations are done for comfort, heat and cooling requirements, for energy and fuel consumption, and for CO2 emission as well. Building design concept is chosen as a result of previous building simulation in order to reduce solar heat gains through large glazing areas in summer conditions, to reduce energy consumptions for cooling, and to provide enough daylight in winter and summer as well. Innovative green curtain shading is placed in front of the southern and western office area facing glass facade. Additional part of architectural intervention is transformation of the flat roof above R&D into a green roof garden. Barrier-free access to the garden is enabled by placing the ramp on the second floor outdoor terrace. Building thermal envelope is renovated. Exterior wall insulation is increased from existing 3.5 inch to 4.75 inch. Flat roof above R&D is renovated into a green roof in order to provide better insulation to reduce heat loads, to provide pleasant microenvironment for occupants' rest, helping to lower urban air temperature and to decrease heat island effect. Existing windows are replaced with new quadruple windows with low emission glass and innovative green curtain shading. Sweet peas wine, an annual plant, is used to form green screen for sun protection. Wine plants are grown over trellis of steel cable to shade glass curtain wall of the building. The illustrations show analysis of the relationship between annual growth of the plant and its produced shadow. During summer months, when solar insolation reaches its peak, green screen has its full height and also its full potential in preventing overheating of interior space. Various building simulations are done for two different building renovation variants, version 1 and 2, in comparison with existing building envelope and assumed system. Existing building assumptions are made in order to compare energy savings, environmental benefits, and cost analysis. Building envelope improvements are the same for version 1 and version 2. Variations are done for HVAC system. Version 1 is considered to have 3 air handling units with fresh air and heat recovery, fan coil system for basic heat losses in winter period and heat loads in summer period, gas-fired condensing boiler, chiller, exhaust fan, ground source heat pump with vertical heat exchanger for hot and cold winter preparation. Version 2 is considered to have 3 air handling units with fresh air and heat recovery, gas-fired condensing boiler, chiller, exhaust fan, multi-split VRF system. Air handling units for clean room and research and development are considered to be mounted packaged type in suspended ceiling. Heating, cooling design, outside drive bulb temperature and daylighting simulation results are the same for both version 1 and version 2 because building envelope preliminary design improvements are the same for both versions. The main aim was to compare results for energy and fuel consumption and CO2 emissions for those two solutions in order to provide better solution which meets energy conservation requirements ASHRAE 189.1 and to examine life cycle costs. CFD simulation is done for temperature and velocity fields in building and results are shown here. Fume hood performance criteria should meet ASHRAE standard 110. Clean room design should meet design criteria for particle concentration limits and air changes per hour for given conditions for Class 5 ISO 14644. Here we see design criteria, particle concentration limits, ASHRAE handbook. And here we see design criteria, air changes per hour, ASHRAE handbook. The modular air handling unit for clean room is mounted in suspended ceiling in R&D area, which is connected to the clean room space. Another modular air handling unit for R&D zone is designed to be in the suspended ceiling in that area. Here we see HVAC system schematic heating cooling sources, version 1. The exhaust rooftop fan is designed for air extraction from toilets and restrooms. Here we see air handling units and fan coil system schematic, version 1. Version 2. 3 air handling units with heat recovery, gas-fired condensing boiler, chiller, exhaust fan for toilets and rest areas. Multi-split VRF system, air source heat pump for basic heat loads in summer conditions are considered. For clean room and R&D department, modular packaged ceiling-mounted air handling units are designed. These preliminary design drawings for first and second floor are shown. For building electricity consumption needs, beside conventional electricity grid, PV system on the building roof is installed and connected to the building grid. The total number of installed PV panels is 253 and total installed area of PV panels is 455.4 square meters. The panel efficiency is considered to be 15%. Total annual energy harvest from PV panels is 93.4 megawatt-hour annually. Payback period for PV panel installation is around 3.5 years. According to all simulation results, energy consumption for building before renovation is compared with building after preliminary design renovation. Results are shown in this table. Heat losses, energy consumption, fuel total needs and CO2 production for version 1 and 2 in comparison with building condition before renovation. Regarding those results, energy and fuel total savings are shown in the comparison with existing building before renovation. Total heat losses reduction, electricity and gas savings. It is shown that total building energy consumption is lower 27% for version 1 and 35% for version 2. Considering these results, version 2 is chosen as better solution. Various types of artificial light could be installed. For this project, different types of light are designed for offices, clean room and R&D spaces in accordance with appropriate luminescence and use of space. High-efficiency recused luminaire for direct high-quality illumination of office spaces, 500 lux. Clean room luminaires are sealed with direct light emission, high protection degree IP66 and excellent lighting performance. Illumination in these areas is of special significance because it must correspond to the specific laboratory equipments. General illumination is 500 lux. The application of the lighting fitting with bactericidal lamps for sterilizing the air and equipment. Light for entrance, corridors, staircases is chosen to meet criteria from ASHRAE standard 189.1. The automatic control of the air conditioning are cascade, in which we have made use of multiple control loops that involve multiple signals for one manipulated variable. Basic functions of automatic system of boiler are shown here. Automatic control of chilled water generation is shown here. Daylighting control dims or turns off the electric lights in response to the level of natural daylight. Benefits are reducing electricity use, providing a more constant light level, and adjusting to provide range in light levels. Dimming control varies the light output over a wide range to provide the desired light level. Analysis is performed for natural gas price $250 per megawatt hour for USA and annual inflation rate of 3%. Total money savings for natural gas for version 1 after 40 years are around $6,427,000 and for version 2 around $11,159,000. Money savings for total fuel consumption for version 1 after 40 years are around $7,501,000 and for version 2 around $12,233,000. Total investment costs for version 1 are around $3,114,000 and for version 2 around $3,033,000. According to money savings analysis, the payback period for total building renovation with version 2 as HVAC system is around 18 years. For renovated building with HVAC system as it is described in version 2, LEED certification is performed. As it is shown on this figure, renovated building scored 81 points, which is platinum LEED level. It is concluded that for building thermal envelope renovation with better external walls insulation, green roof and new quadruple low emission windows, 69 kW of heat losses can be reduced. For two types of HVAC systems that are proposed, version 1 and 2, it is shown that total building energy consumption is lower 27% for version 1 and 35% for version 2, comparing to building before renovation. According to money savings analysis, the payback period for total building renovation with version 2 as HVAC system is around 18 years. Beside those impacts, very important impact is innovative green curtain shading system and green roof with rest area, which contribute even more to occupants' comfort and total surroundings better appearance and environment, and it is not measurable in money.